Magnitude of static friction and kinetic friction. A wooden block is at rest on a table. One end of it is attached to a spring balance. When the spring balance is pulled with a small force, F, the block doesn't move. If F gradually increased, at a certain stage, the block begins to move.
The object is initially acted on by a very small applied force. The force of static friction is also very small and equal to the magnitude of the applied force. The body does not move.
When a small force F is applied, the surface provides static friction Fs, that is, equal in magnitude but opposite in direction. So, the block does not move. As we gradually increase the applied force F, the static friction Fs produced by the surface also increases. They are equal in magnitude and the body does not move. It is called static friction because the body is at rest, or static, even though acted on by a force. This will continue until the friction reaches a maximum value. When the force is greater than this maximum value, the body begins to move. At the microscopic level, the interlocking is overcome, and the body begins to move. Now, the friction is no longer static friction as the body has started to move, but there is still a frictional force. This is kinetic or sliding friction, and is lesser than the force of static friction. It is kinetic because the block is in motion. Let us plot the frictional force against the applied force on a graph. As the applied force increases from 0, the frictional force also increases from 0, always being equal to each other as long as the body doesn't move. When the static friction reaches a maximum value, the body starts moving. Immediately the static friction is replaced by kinetic friction, which is lesser. The maximum value of static friction depends on the surface. We can represent this mathematically as Fs max equals mu s times n. Note that static friction varies from 0 to a maximum value depending on the applied force. Mathematically, Fs is less than or equal to mu s times n. The magnitude of kinetic friction is always the same for a surface, regardless of the magnitude of force. It is given by Fk equals mu k times n. Here, mu s and mu k are dependent on the surface. A rough surface will have higher values of mu s and mu k than a smooth surface.
Starting to feel it? Now go master it with Askmaski.